The other day, I was telling people that I almost canceled the class because I had pain in one of my teeth, and it was quite bad. I had that for 2 days, and I was able to give the class because I put an aspirin next to it, and that solved the problem to a good degree. And fellow says there says they have herbal rubs for your gums. And Amazon for pain, coconut oil pulling might work. Well, I didn't have to do any of those. What happened was I went to the dentist, and he went in there and opened up something in my gum. I guess it's the teeth, not my gum, but something in my teeth and my tooth, and he put some dentist poison there to, I guess, put the nerve to sleep or something, closed it up, and he told me to come next week. He's going to pull the nerve out. So that's, I guess, the solution. But the the thing is that when I was down there, I was thinking about extinction, and I'm saying, what's going to happen with those people who survive the upcoming extinction? There's going to be pockets, I think, everywhere on Earth where people will survive, groups, etc. And will they have dentists on board? Or they're gonna, if you get a toothache, you're gonna end up like this guy in the movie who Castaway or Marooned or whatever the movie was called, where he had to break his tooth with a stone. So yeah, you don't want to be caught after the extinction event, the collapse, essentially the economic collapse. You don't want to be out there and not have a doctor. See, we're so used to these things. You have a pain or something, well, you go to the dentist, you go to the doctor. I had an operation a couple years ago now on my prostate, and man, and they even pulled a stone out of there, and so that's pretty heavy stuff, pretty heavy operation. And imagine the end of the world, you don't have any doctors. I can't imagine how the Neanderthals, when they ran into trouble, broken foot or whatever, or maybe a toothache, how did they handle that? Anyways, think about that. You need to befriend a doctor for the end of the world, okay? Okay, I talked about Google, and they've been fined by France, $600 million, okay? And Google was not very happy about that. And someone says, according to the government, the problem with Google isn't that they're an evil multinational New World Order apparatus. It's that the old school multinational NWO apparatus isn't getting so much of the media dollar anymore. Your best interests are never at heart. Yeah, I think the issue with the real issue is whether we should tax the multinationals at a higher rate, because right now with this COVID thing, a lot of people, don't have income. They lost their jobs, and if the government doesn't collect from them, it's got to collect from someone else, and it's probably going to be from these big corporations which are making a killing, in fact. And so the question is whether they should be shouldering a heavier load at this point. And again, will that stop the collapse where we're headed towards, as I say? No, it just may stretch a little more, a little less, but I think the collapse of the global economy is assured. I don't think we can avoid it. Okay, talking about Neanderthals. One fellow says, wow, I've suspected that much of the Neanderthal hypocrisy was a distant shot on the out of Africa model. I guess they are removing all suspicions and just coming out and saying it. Okay, and another fellow along the same lines, talking about, the out of Africa, he says, if man came out of Africa, it probably was not to find food. Because that's what I'm saying. Cro-Magnon came from Africa, came over to Europe, and was able to enter Europe once the Neanderthals were gone. Okay, so that's my take on that. And he's saying they probably didn't come out for food. Okay, so what did they come out for? So it probably just got tired of African behavior like we see in South Africa and other parts of Africa we see today. The behavioral differences between Africans and Europeans can be seen pretty clearly in South Africa, for example. Yeah, the problem is people extrapolate what we have today to the past. Like the other day, one fellow said that the Neanderthals, he could not imagine a Neanderthal not raping a woman out there. They're thinking of in terms of what they see today. The question here is whether in the wild, a Neanderthal would sleep with someone that is not of his own species, us. We were not of the same species. So first you got to tackle the issue of species, and then you got to tackle the issue of in the wild. And this is something similar. The fellow is saying that behavioral differences. I don't think they cared too much about behavior in those days. They were. You're talking about the Paleolithic, fellow. You're talking about people who are living at subsistence level out there in the jungle. They have to kill something to live one more day. This is what's on their mind. Okay, and yeah, they do have sex, but hopefully with the right species. Okay, but it's very simple. Humans came out of Africa and went all the way to Asia, to China and Indonesia, and also went into Europe, because we do find footprints, and we have a partial skull bone that I showed the other day, female, about 400,000 years ago. They think it's Heidelberg or Heidelbergensis type, okay? And so, there was someone already in England 400,000 years ago. We already have evidence that there's been a bipedal animal, monkey, gorilla, us, whoever, 800,000 years ago in England. And so we're finding these bones, these fossils, these skulls, and other bones as well, right? In Western Europe, and they date to 800,000 million years ago, maybe. So we have to think that at least Homo erectus, which is that level, was already in England or in France or in Germany, in that region. And where did he come from? Well, you have to assume that he came out of Africa. Okay, he had to come out of Africa, and this is the reason. Here you see the skulls that we have today. Homo habilis, he's 2.5 million years ago. He's got only 600 cubic centimeter capacity in his brain. And you can see how the brain grew over time. And we only find habilis in Africa. Erectus, we find them in different parts of the world, but more of them in Africa. And we have to assume that someone in the level of habilis, if it wasn't habilis himself, someone around that level gave birth to erectus eventually. Erectus gave birth to Heidelberg in Europe, and you would have to think that Heidelberg gave birth to Neanderthal in Europe. That's what the fossil evidence seems to show. Okay, so this is my take on that. There is no level of habilis anywhere. At least we haven't found any in the world yet, other than in Africa. And you might say, well, maybe they haven't found it, they haven't looked deep enough, or maybe we'll find habilis level in China tomorrow or whatever. Could be, but right now the evidence shows that habilis started in Africa. There is no habilis outside of Africa. That level of development, okay, of skull development. So we have to think that our species, at least our whole dynasty, if you want to call it that, started in Africa. Okay? Yes, that's my take on it anyways. Fellow also says, also we can look at the cold ice records, because I was talking that, Neanderthals did not wear clothes because they were born in the snow. They were born in the in Arctic weather. They didn't know what cold was. That was my argument last time. This guy picks up on that and says, we can look at cold ice records of William Hoff. Yeah, he's talking about really Will Hoff, not William Hoff. That's not his name. His name is Will Hoff. Okay, the Iceman. The human tolerance for cold might be much greater than we think. Well, there's a difference between Mr. Will Hoff. This is him, by the way. Let me show you who this man is. Okay, they put him in ice. Okay, the Iceman. And they throw all kinds of ice in there. Okay, and the guy can withstand maybe 2 hours of this. Okay, so he does this to disperse propagate his, or proselytize on his method. Okay, I guess he's got a business in which he tries to get people to think in terms of how they can withstand extreme cold. Okay, so he does these shows, freak shows, Barnum and Bailey type freak shows. And it's interesting here, you see his method, okay? He talks about breathing and cold therapy, okay? And it's interesting that while looking at this, I was seeing that he goes out into the cold and he goes out there with shoes. I mean, he does have shorts on, right? But he does wear shoes, okay? And I think that the main reason he wore shoes is that maybe he can stay in the snow, in the cold with his bare feet for a little while. I don't think he can stay there all day with his feet in the cold, okay? Especially if he's not running. That's another issue. You know, if you're sweating because you're running, even though it's cold and it's in the snow, you can withstand it a lot more than if you're just standing still, you know, on the snow. And I'm saying that all that is completely different than what Neanderthal was. This is Neanderthal taking a bath, you know, in the winter cold in the snow. He could stay in there forever. You know, Neanderthal was like the woolly mammoth. Woolly mammoth didn't use clothes. Polar bears don't use clothes today. Wolves don't use clothes. Penguins don't use clothes, and they have their feet. Showed this the other day. Their duck feet completely in the snow, and they're so used to it because they live in the snow. This fellow here, Will Huff, he can't do that. And again, he's got to prepare. He's got to train him mentally and physically to withstand all this stuff. He can do it more. He can withstand it for longer periods than other people, common man out there who haven't practiced or whatever. We're not talking about the same thing. We're talking about a guy who was born, who's got it in his genes, who probably was a woolly guy like that guy there, and who lived in the snow. He had no reason to wear clothes. Okay, so clothes were not invented by Neanderthals, and again, we haven't found needles in any of their sites. We found all kinds of tools, weapons, different things that we found from them, but we haven't found any needles. You would think that, you know, they would have to sew the garments together, the furs or whatever they were supposed to put on. No, these were gorillas, and any more than a gorilla puts clothes on in the African jungle, you know, these fellows never had to use clothes at all. Okay, so, and that would have been a distinguishing feature if humans met them, because humans moving into that region, I'm sure they started putting on clothes. And that's what you see really, that about 35,000 years ago, 36, maybe 38,000 years ago, about 2,000 years after the Neanderthals disappeared, which is around 40,000 years ago, humans came in there and they started, and we have some evidence that there were needles. So the needle appears, you know, maybe around that time. And that would strike me as odd. But for a Neanderthal to find a needle in the Neanderthal haystack, good luck with that one. I don't think it'll ever happen. Okay, another fellow says linear regression. He's quoting an article here, by the way, and he said linear regression of genetic complexity on a long scale extrapolated back to just one base pair suggests the time of the origin of life 9.7 billion years ago. And you might say, well, what's the problem with that? Well, the problem when we contrast that with the official version, the Earth is only 5 billion years old. Okay, so these guys are extrapolating. They're doing just some math there, and they're saying that it's almost 10 billion years ago that life started on Earth. And so where does that leave the origin of the Earth itself? Okay, did life start without the Earth? So he says life before the Earth. Okay, he's suggesting life came from abroad. Not necessarily from the ETs coming here and visiting us. In a way, yes. In a way, no. He's talking about panspermia. Okay, that some kind of life eventually arrived on Earth, but life already was out there in the universe, maybe before that. But it says the word, this fellow just makes a comment, says they worded as extrapolated instead of predicted, in this case, on tour, the solar system with, oh, okay, he's just mentioning the place. In other words, he's saying that they're just doing math. And that's true. You know, one thing is just to do math. We have a lot of problem with that because they take a lot of the physical interpretations, they extrapolate them from math, and that doesn't always work so neatly, okay, for Mother Nature, especially Mother Nature, who doesn't know anything about math. Okay, so here, when you go to that site, the one he mentioned, the paper, I went in there and looked at it. It says these are the main points they want to make in their paper. Life took approximately 5 billion years to reach the complexity of bacteria. Okay, there was no sign of intelligent life in our universe prior to the origin of Earth. Intelligent life, he's qualifying that. He's not saying there was life, but not intelligent life. Okay, intelligent life has begun appearing in our universe, has just begun. Okay, thus Earth could not have been deliberately seeded with life by intelligent aliens. Earth was seeded by panspermia. Now there was some kind of bug crawled out of a rock, and that's how we became impregnated with life here on Earth. That's what he's suggesting. Okay, talks about the Drake equation for guesstimating the number of civilizations in the universe is likely wrong. He's saying that Drake had it wrong, Frank Drake. I'll go over that in a second. The doubling of time of complexity has reached approximately 20 years. The predicted technology singularity talks about this paper talks about that as well. So the authors of this paper they're talking about panspermia, the Drake equation, which has to do with what what the possibility is of life being popular out there in the universe. How many civilizations could there be out there with life? That's what the Drake equation tries to figure out. And again, it's all mathematics. And the question is, can you extrapolate that into physics and say, oh yeah, I can safely say the following because of that math? And you know, a lot of people criticize the Drake equation on that basis, that it all amounts to your assumptions, what assumptions you make for each one of the points that Drake has in his equation. And so here's the Drake equation, okay? Essentially, this is what Drake was trying to figure out, or what he suggests are the important points that anyone tackling the problem should address, okay? Rate of star creation in our galaxy, fraction of those stars that have planets, okay? Now, I would think that all stars have planets. They're saying that they probably don't, and that we got to look at the fraction of stars that have planets, okay? Average number of planets that might support life per star that has planets. Not all planets are suitable for life, okay? Fraction of the above that actually go on to develop life, because even if they can, maybe they don't, for whatever environmental reasons, right? Fraction of the above that develops intelligent life. Sometimes I wonder how much how much intelligence all these people have, right? Fraction of the above revealing their existence via signal release into space. In other words, even though they develop life, do they develop the capacity to transmit and receive that kind of thing, you know, information? Lifetime of such a civilization wherein it communicates its signals into space, okay? Because then they might want to, but maybe their civilization dies too early, maybe extinction reaches them for whatever reason, and so they don't get to communicate even though they have the tools to be able to do so, okay? So that's what the Drake equation talks about. Here are his values. This is what he calculated. Drake tried to calculate what percentage or how many stars there could be out there that have life, or planets that have life. And he says 1 star formed per year on the average over the life of the galaxy. He addresses point by point there, in other words. 1/5 to 1/2 of all stars formed will have planets. Stars with planets will have between 1 and 5 planets capable of developing life. 100% of these planets will develop life, 100% of which will develop intelligent life, and 10 to 20% of which will be able to communicate. I'm not sure why he made that distinction, but then he moves on to the last one. He says 1,000 to 100 million communicative civilizations. That's what he thinks. Okay, that's what he thinks should be out there. Is he maybe a little too optimistic? Okay, I think sometimes these fellows, again, do a lot of math, and they don't pay attention to the physics of it. Okay? And what I'm referring to here is that all these folks, a lot of them, in this case, Drake, he had a PhD. He spent his entire life on this SETI thing, which he worked with Carl Sagan as well to send some evidence that we're alive here on Earth out into space with one of the probes. You know, the question is there any possibility whatsoever of ever seeing or receiving information from another civilization? And the answer is no. There is no possibility whatsoever. These people are wasting their time, wasting money out there, trying to locate some sounds. It's like they don't know physics. They studied physics and they don't know physics. They don't know anything about it. All they do is math and extrapolate it from the math. There is absolutely no possibility whatsoever of receiving information from any other civilization. Are there out there? Yeah, I'm almost sure there have to be in the universe with so many planets and stars, and that they're out there. But life is a very scarce resource, and you can tell that just by looking at our solar system. We're the only planet developed life, and all the others are dead planets. They're really, I said it right, they're dead stars. That's what they are. But they didn't develop life, and you would think that with that life should be very common out there, and it's not. They looked at like 20 light years in the vicinity radius, None of the stars seem to have life of any kind. That we haven't received any information or anything from those stars, from those regions. And you say, why could that be so? And I'll tell you why. The first one is that, we've been around only 200,000 years here on Earth, us humans. And we've had technology to communicate maybe for only 100, 150 years at the most. Before that, we had no way of communicating anything. We had no notion of the light signals or electricity or magnetism in such a way that we could send information out of the Earth. We only had that type of technology only 150 years. Now, 200,000 years, supposedly the time we've been on Earth, humans have been on Earth, that's a drop of water in the billions of years that even general relativity says we've been around. We've been around 14 billion years, according to them. I'm saying we've been around forever. There's been no beginning to the universe. So here we are. 200,000 years is nothing. And that's when we were just hunter-gatherers for most of that time. We developed technology to be able to communicate outside the Earth maybe 150 years ago. I'll give you 200 years if you want. 200 years. That's even a smaller, that's not even a drop of water in the ocean. That's absolutely nothing. And now look at the fact that we could be staggered. There's a civilization rising here. It dies, it goes away, it becomes extinct, and then suddenly we come up and we look around, we say, oh, let's look see if there's a civilization out there that can hear us and see us. Well, not only are we separated by time, we're separated by the scarcity of life to begin with. It's got to be maybe the third planet, third rock from the star, so to speak. It's got to be in the right place at the right time. Then, even if it develops a civilization, we're talking maybe 150 years in which they develop technology like we did here, and then we become extinct. And so even if, to match 150 years of their civilization with 150 years of our civilization in the universe, it's almost impossible. I would say it's so scarce, it's beyond calculations. I'm sure a mathematician will go out there and try to figure it out, but it's not even probable. It's impossible. So the question is staggering. Staggering in development. All civilizations come to an end, extinction. So this notion that they developed, that there's all these levels, that civilization takes over the planet, then over the star, then over the galaxy, and so on, absolute nonsense. Yeah, absolute nonsense. These people see too much Star Trek, and they're not thinking enough time. Okay, one fellow tries to address the question that I ask always at the end, which is answer to the question of why the animals in the sea approximately died when the land animals died, because the sea animals were the food pyramid of the land animals, or maybe vice versa. And when one went, the other one went too. So the dinosaurs ate fish, huh? No, I don't think so. I like the fact that you gave it a try at least, but at least I won't go with this theory. I don't think that's what happened. No, again, the mosasaurs, they ate ammonites, which ate probably zooplankton or both, just plankton of any kind, and not of any kind. They ate a special kind, and it was the kind that disappeared. Another plankton came up, like the grasses came at the end of, from the middle of the Cretaceous towards the end of the Cretaceous. The angiosperms covered the land. They displaced the conifers, and somewhat like that, what you have in the seas is the same thing. The small plankton replaced the big plankton. And the ammonites ate plankton, the big plankton, the ones they were used to, and what ate them were the mosasaurs. That's just one food chain, just for reference. And so I don't think any of those were involved with the land dinosaurs, T-Rexes and whatever. No, one had nothing to do with the other. Okay? So no, I don't subscribe to this fellow's theory, but nice try. Okay, one fellow quotes several different papers, and they all say essentially the same thing, that none of the dinosaurs ate angiosperms. Okay, so he just put three different references saying that none of them ate angiosperms. They all ate conifers. There's no evidence that dinosaurs ate angiosperms. I read one paper once, I think it was from an Indian fellow, and this fellow argued that he found coprolites, or I can't remember really what, but he had evidence that one dinosaur at least ate angiosperms. And again, he was criticized by a lot of his peers. I don't think we really have any evidence that dinosaurs ate angiosperms. I don't think we'll ever have that evidence. And people are going to try to stretch the evidence that they see or interpret it in such a way as to fit the angiosperms into the mouths of dinosaurs, because that would be a big hit. He'd get his name in lights. I don't think he'll ever find that because, again, dinosaurs radiated with the conifers. And here they were around for millions of years, not only in the Jurassic, but then again in the Cretaceous. And towards the end, when the conifers were dying out in the last half of the Cretaceous, maybe 60 million years, they gradually were going away, all the conifers, and they were replaced by the angiosperms, which is what the mammals grew or radiated with. So I think that's really what happened. The angiosperms muscled aside the conifers, which meant that the dinosaurs, because they ate conifers, were muscled aside as well. Only because the forests were shrinking, the jungles were shrinking. Jungles of cycad likes, Williamsonias, and other types of plants that they ate, those were disappearing. The forests, the jungles were becoming smaller and smaller, and the ground was being taken over by these weeds, which is what we eat today, the angiosperms. That's a better solution to extinction than saying that an asteroid hit the Earth. Okay. And along the same line, the fellow says, yeah, it looks. He says that it looks that these people are trying to prove it at all costs that the dinosaurs ate angiosperms, but they have no way of proving it. They have found no evidence so far. But what a lot of people are noticing in the paleontology world is that what it says there, the new work helps confirm another recently published and controversial claim that most dinosaurs were already in decline 40 million years before the meteorite struck and finished them off. Yeah, I don't think there was a meteorite or asteroid that finished them off. It has nothing to do at all whatsoever with the extinction of the dinosaurs. The dinosaurs were already on their way out. And it was a gradual disappearance. And if you're going to talk about a gradual disappearance, well, I think a good bet is that plants were going away, plants that they ate. Dinosaurs cannot change at the last moment and say, oh, I'm going to switch over to angiosperms because I cannot find enough conifers. It doesn't happen in the wild, okay? Especially if you've got millions of years of conditioning to a certain type of food, millions of years, dynasties after dynasties after dynasties. And the last dynasty says, oh, I can't find conifers. I think I'll start eating magnolias or roses. It doesn't happen. Again, rabbits don't switch overnight from lettuce to pine leaves. Okay, they don't like them. And I don't think you would either. But you tried. You showed us the experiment. Do the experiment. You say, tomorrow I'm not going to eat tomato. I'm not going to eat lettuce. I'm not going to eat any of that stuff. I'm going to start eating pine leaves. Yeah. Show us. Okay, again, final, always try to do Extinction 101 before 102. 101 is mass extinctions of the past. Okay? Then you can always move on to human extinction. Because if you can figure out how it happened in the past and how the animals died in the past, maybe you can extrapolate that mechanism to us today and find out whether we can overcome that same mechanism, whether our intelligence, our technology, our ability to foresee events and take action, whether that has anything to do, whether that is an antidote to extinction, whether you can do something about extinction. And I'm saying we cannot. Okay? And again, the good question here is this one, the key extinction question: why do the animals on land disappear more or less at the same time as the animals in the seas? That's the question you really got to answer. Okay.